Okay, now we've got 9-2, translation. You all should remember from a previous lesson that a translation is a type of transformation where all the points of a figure are moved the same distance in the same direction. A translation is an isometry, so the image of the translated figure is congruent to the pre-image. All right, we need to identify which ones are translations and which ones are not. So, is this a slide? Nope. Looks like a flip. When it's a flip, that is a reflection. Is this a slide? Yes, it looks like we slid down and then over a little bit. So that is a translation. Is this one a slide? Yes. If we start here, we went over and up. If we start here, we went down and over. And is this a slide? No. Whoops, I said no and wrote yes. That's no. Okay? All right, translation. A translation is a transformation along a vector. We just learned vectors at the end of Unit 8, such that each segment joining a point and its image had the same length as the vector and is parallel to the vector. Okay, so we have point A, and we're going to translate it to A prime. Okay, so what we did is we used this vector here to translate it. So here's one vector, two vectors. So it looks like you doubled it there. Okay, so to draw the translation along vector V. Okay, in class tomorrow I will show you a video, but let's see if you all can understand what I'm doing here. First thing you need to do is you need to draw a line parallel to the vector through each vertex of the triangle. Okay? So through each vertex, I would take my straight edge, alright, and I would line it up, parallel, and draw a line. Just try to eye it and make it longer than that vector. Each coordinate, okay? That's what these red lines are right here. Okay, measure the length of the vector, then from each vertex, mark off the distance in the same direction as the vector on each of the parallel lines. Okay, so you need to go back here with your straight edge, and you need to measure this vector from the initial point to the terminal point. Okay? And then you're going to go from each vertex, measure from each vertex, and make that point. Then you connect your 4 points there. And what you've done is you've taken the blue pre-image and you've translated it along vector V to create this red image. Okay, so we're going to do one on our own. And again, this is not going to work well with my straight edge on the smartboard, so I'm going to have to eye it. Okay, so I've got parallel, parallel, so I'm going to eye it. Make it longer. Y'all should be using your ruler here. Okay, and then I measure my vector. From each vertex. And then I connect those 4 points, and what I just did is I moved, and it looks like it could be more precise, hopefully y'all's is more precise than mine, is I moved this pre-image, the blue, the distance of this vector W, and got this image red. Okay, recall that a vector in a coordinate plane can be written as, this is your component form, AB. Remember, A is your horizontal distance, B is your vertical. All right, and we start with the initial point and end up at the terminal point. So, horizontally, you're adding a value to your x coordinate. Vertically, you're adding a value to your y coordinate. And then a general translation would be where you're adding a value to your horizontal and vertical coordinate. Okay, translate the triangle with the vertices D, E, F along this vector. Okay, so first, let me see if I need to draw this, and I do. So this is going to be my y-axis. This is going to be my x-axis. Okay? All right, so let me graph my first point here. I have positive 5, negative 3. Whoops, that's E. Negative 3, negative 1. Negative 2, negative 2. Okay, so I have this triangle here. And we are going to translate it across this vector here. So I need to add 3 to my horizontal, my x-coordinate. So negative 3 plus 3 is 0. I need to add a negative 1 to my y-coordinate. So negative 1 plus negative 1 is 0. 5 plus 3 is 8. Negative 3 plus a negative 1 is negative 4. Okay, we need to back up. Negative 1 plus a negative 1 is negative 2, not 0 there. All right, and then we need to go to F prime. So we have negative 2 plus 3, which is 1. And we have negative 2 plus a negative 1, which is a negative 3. Okay, now we need to graph our image here. So 0, negative 2. That is our D prime. And then we need 8, negative 4. E prime, and we need 1, negative 3. And that is our F prime. So what we just did here is we took the blue triangle and we moved it along the vector 3, negative 1 and ended up with the red image there. Okay, let's see y'all do this one on your own. So we are just translating. We are not graphing. I will be quiet. You need help? Look and see what I'm doing here. So you should have R prime at negative 1, 2, S prime at negative 3, negative 1, T prime at negative 2, negative 4, and U prime at 0, negative 2. And you're adding negative 3 to your horizontal and vertical values there. Okay. The sailboat has coordinates 100 degrees west and 5 degrees south. Okay. The boat sails 50 degrees due west, then the boat sails 10 degrees due south. What is the boat's final position? What single translation vector moves it from its first position to its final position? Okay, so let's start at the starting point. A sailboat has coordinates 100 degrees west. Okay, y'all should know north, south, east, west. So 100 degrees west would be negative 100. And 5 degrees south would be negative 5. So this here is our starting point. Okay, so for my horizontal, each tick line is going to represent 25. Okay? And then for my vertical, each tick line is going to represent 5. So for my starting point, negative 100, negative 5. So I go 25, 50, 75, 100, negative 5. So right here, I'm going to put an S for my starting point. Okay? Then the boat sails 50 degrees due west. So it's 50 degrees due west. So I end up at negative 150. Then the boat sails 10 degrees due south. 10 degrees due south. Okay? So here is my second point. So from this point, I go 50 degrees west, then 10 south. And I'll just call that P for second point. Okay? So I went 50 west, 10 south. All right, so my final point is right here. And we want to know what the vector would be to get me here. So I go from here to here. So that vector would be negative 50, negative 10. Okay? All right, let's see if you can do one of these on your own. Okay, so let's see. From here, we went up 2 places and then 3 places to the left. So here's your starting point. Here's your ending point. You went up and then you went over. Okay, so we end up at 0.6. And then here's your final vector. All right, guys, have a good one.